Hey, I'm Roman. So there is this article that was released not so long time ago that is called Measuring the Impact of Early 2025 AI on Experience Open Source Developer Productivity. Many other YouTube channels and many people actually started to discuss this one. It got me, thinking and understand my usage of the AI in my day-to-day software engineering workflow. And while I was skeptical about this whole AI hype train, especially in software engineering, I still believe that the best way to judge something is to try it out for some time in different ways, and then make some conclusions. The interesting thing that this research shows that the experienced developers actually got slower by using the AI tools, but they thought that they were doing things faster. And this is, I think, one of the most unexpected things from this research. You feel more productive, but actually you taking more time to finish some things. So this is what I would like to discuss here and compare the research results with what I experience in my day-to-day usage of the AI tools. The tools that I'm using right now for the software engineering specifically are the Aider Chat and Avante plugin for NeoVim. They both provide kind of cursor-like experience with AI assistant coding, but in a bit different ways. So the Aider Chat provides you the CLI. I think it's close in a way to the Cloud Code CLI, where you can select a model and you can interact with your repository, you can add the specific files, and you can talk about the code, you can give the instructions what to do with your code. And then the second one is Avante, which is the integration of the Gen AI for the coding into the NeoVim itself. So I think this one is actually closer to what Cursor does with the VS Code. And again, both tools provide you an ability to configure what models you want to use, and they both give you an option to use some local models or your private models or your private hosting. For example, I tried to use Llama and integrate it into this one, and it all works. So the good news about these tools is that you can select any model that you prefer, and actually I tried to use 3 different models. I used 3 different sets of the models, let's put it like this. I used the set of the model from the OpenAI, different versions of the ChatGPT. I used Llama, specifically Code Llama, and I don't remember, something like the Gemini 3, and that was another one, which is the reasoning model that can be run locally on the MacBook Pro. And the third one was the Cloud Code models. And for me to make the conclusions, I need to draw 4 areas where I actually try to apply all of these AI tools. Because of the different areas of the applications, the results are very much different. These days, I'm usually working on the 4 kind of different areas of my work and personal projects. So the first one is development of the macOS and iPadOS vector graphic editing tools and the animation creation tools. Since it's a heavily Apple-based product, we're using the Apple ecosystem as much as possible. So we're using like Swift, we're using UIKit for the UI stuff. But the interesting part is we're using all of the possible frameworks from the Apple for the rendering, for the image processing, for working with the path which we need to work with the busy curves. The second one is our backend. So both our applications have the backend support. We provide things like file synchronizations, ability to work with other people on the same project, and so on and so on. And here I would say the technical stack is more or less standardized with what you can expect from a modern backend. So we use AWS, we use GCP, the backend written is mostly with the Golang, we use Teramate for the platform infrastructure as a platform code. So you can see there is nothing super unusual of what you would expect from the modern backend development. The third area is what I would call the disposable software. It's the things that you write once, you use them, and probably you will delete them. Most of the time it's just some scripts with the Python or with the TypeScript that, I don't know, I need to call some APIs in a specific order to automate some things, or I need to process some data, and yeah, usually it is generating some script, or even in the bash, generating some script that does the job, and most likely I won't need to support it for a long term. It's just a one-time thing. And the last one is the personal projects. Currently, I'm working on the Allegria, that is the macOS application that serves as a default web browser and provides you ability to create the rules how you would your links be open in a different browser. So for example, you can declare something like open all of the YouTube links in the Safari, or always open GitHub link for this specific organization in the Firefox. And there are other features. It's a macOS application written mostly in Swift, but it's not that complex working with the config file because you can declare all of the rules in the toml file, not in the UI. So it's working with the config, writing some business logic on how exactly I want to route opening of the links. And there are some features like removing tracking attributes or opening the shortened URLs and so on. So it's mostly like interaction with the operating system, interaction with the URL parsing config parser, and dealing with the network requests. That's it. Okay, let's just go into the results. So the first area, as you remember, is the implementation of the vector-based editor graphic tool with the Swift and the Apple ecosystem and Apple platform, Apple frameworks. And this area is actually the worst. The issue with such applications is that I believe the training data for such applications in all of the training data for the coding oriented models is very, very low, because it's a programming language that is not that popular. For example, something like the Python or the JavaScript or even C++. And then it goes even lower for the framework that we're using. For example, we're using like the Accelerate, we're using the Core Graphics or Core Image. All of the models were very bad at solving the tasks that I asked them to solve. Well, probably basically because the training data for this area is very, very small. I would expect it to get this information, from other languages itself, but at the same time, multimedia editing application is not a common thing comparing to all other code base that you could find even online. For example, in our application, when you move an element, there is a way to snap to the specific guides, as we call the dynamic guides. So you could snap it to a different element or to the center of the canvas. And I needed to implement it for a different element type, so I tried to use different LLMs to do this. And not even they produce the code that doesn't compile. The logic that it suggested for to implement or actually implement, it was just wrong. So for example, first I had to fix the compilation errors. It wasn't that much, but still. And the second time, the logic was just something very random, and it didn't work as expected. But yeah, even given the fact that I know how to do this, I tried to help the LLM to implement this. It didn't work out. And it's just one of the examples of the things I tried to do in this specific area. For the backend parts, I would say the results are neither good or bad. I would say it worked well on isolated tasks. For example, when the task is isolated in several files, and that involves working with the several, in case of the Go, with the several of the structures, and it worked fine. It was able to, for example, find an issue or to generate the code that changes the logic. And then goes the disposable software. And here I can tell that it feels like the LLMs were built to generate the disposable software. It was really good. So every time if I need to generate a simple script that does something, usually in a popular scripting language like Python or the TypeScript, it usually does it very well. For example, recently for the Allegria, I needed to prepare all of the things for signing an application. And if you know a little bit about the Apple and the signing process, it's a pain in one place. Plus, I don't want to distribute the application through the App Store. So there is a way to distribute it outside of the App Store, but it involves even more complexity deal with the signing. So I asked LLM to generate a script that combines the notarization and sign-in from the Sparkle, generate the upcast, which is the way how Sparkle distributes the updates, and it did it really well. I think I finished the first version of the script that I was using, and it kind of worked. I know that I can build this script by myself because I did it in the past, but the problem with this type of the script, it usually, you don't do it more often. Usually you do it once per application, and maybe you change it once in a couple of years because some API from the Xcode has changed, and that's it. So it's always painful process to remember all of the steps, like what steps should be done in which order, you need to make it right. If I would try to do it by myself again, I would implement it for sure. Here, I'm pretty sure it will take much longer than 1 hour. And the last one, the development of the alligator application itself. And the results here are a bit controversial, I would say. Because, for example, on one hand, recently I released a new update with a feature where I give the ability to not only support the mappings into the domains, where, for example, I can declare that all of the GitHub applications should be opened in Safari, but instead I want to support the path as well. So, for example, github.com/some organization should be opened in the Firefox. Just all of the rest of the GitHub URL should be opened in the Safari. And it implemented it, and implemented in the correct way, but it failed to generate again the unit tests. Well, here I would say I'm not that surprised because I tried to generate the Swift test, and it's not the XC test, that's the old framework that was used for a long time in the Apple ecosystem, and I used the new one, which was released, I think, 1 or maybe 2 years ago. So it is kind of expected. I mean, there is I would say the general consensus that if you're trying to use the newest frameworks with the LLMs, they are not good at this. So you need to use something more, like the more popular thing you're asking LLM to implement, there is more possibility that it will do this. And once you started to use some rare technologies, it falls to do this. But once I actually fix the issues, I make it compilable again, the tests were failing, given the fact that, well, the code base is very small for the alligator application. So I was able to add it fully into the context and the unit test and the error. And I asked LLM to understand what is the cause of this failure. It didn't tell me anything correct, but I had to fix it by myself. So if I would start to make a summary, I still think that all of these AI tools are tools and they have pros and cons. And from my experience using these tools, I would say the biggest impact I see right now is in disposable software. When I need to generate something for once and I don't care about the code, I just need things to be done and I will not have to support this code. I think this is the best way to do this. Then it goes in the order of the popularity of the tasks and the frameworks and the programming language that you want to use. I think this is why on the YouTube you could find mostly examples using, generating the code for the front end, for the JavaScript and the TypeScript or even Python, because those languages are pretty popular in the number of the open source project and the code bases itself. At the same time, the complexity of the things that you build using these tools are not that high. For example, if you would need to implement something with the C or the C++. And another interesting part that's actually a good amount of the software engineer who tries to use Gen AI tools in their day-to-day work, but they all have skepticism that I would group into two parts. The first concern that I hear the most is that the bigger the context itself, the less good of the results you can receive from the LLM. It supports the statement that I did before, so the more complicated feature that you need to build that spans across different modules, different classes, less productive the LLM become. The second one is they all agree that the code quality is not good for the long-term support. It can do the trick, it can do the work, but it's something that's hard to maintain by the person. And the last one is that sometimes it's really hard to get something what you want from the LLM. So we spend a lot of the time actually explaining in very little detail what you need to do. I mean, what you want it to do. And sometimes you have to start over because the context is full. And all of the messages, even the answers from the LLM in the context, influence how the next question will be answered. And one last thing, it's not always like the time that is saved from the code generation manually versus code generation with AI tools can be converted into faster development, because the code writing is one of the steps, but it's not the only one. And the research that I mentioned in the beginning, to be fair, they didn't have the big audience of testing. It was like 16 software engineers doing 136 issues with or without AI tools, and then they compared the results. But it's still something. So even here, this group of the people in the end got slowed down by using Gen AI tools. I would say, from my experience, that in some places, the using the LLMs increases my productivity in this particular task, but in the others, they just slows me down by a lot. And I would like to ask you, what's your experience with the Gen AI tools for the software engineering? Thank you for watching, and I see you in the next video. Bye-bye.